Welcome to the Zenfoancer LASIK Calculator demonstration. This intelligent surgical planning tool is part of the Zenfoancer platform, developed to assist refractive surgeons in evaluating LASIK safety and treatment planning. Let's begin from the very start. Open your web browser. Now type the website address www.zenfoancer.com. Press enter. The Zenfoancer homepage will now load. Once the homepage appears, take a moment to look at the navigation options on the screen. You will see a menu item labeled LASIK Calc. Click on LASIK Calculator to open the Zenfoancer LASIK Calculator. The calculator page will now load and you will see the interface where patient data and surgical parameters can be entered. At the bottom of the screen, you will see a cookie notification. This notification informs users that the website uses cookies to improve performance and user experience. Click Accept Cookies to continue. After this, the website will display a medical disclaimer. This disclaimer explains that the calculator is intended for educational and clinical planning purposes only. It should not replace professional medical judgment or a surgeon's clinical decision-making. On this page, you will also see the creator information. The Zenfoancer LASIK Calculator was created by Mr. Gaurav Kamble. After reviewing the disclaimer, click Accept Disclaimer. You will see a form where patient information can be entered. Let's walk through an example. Patient name, Rahul Sharma. Hospital, Zen Eye Clinic. Patient number, add patient hospital unique code. Mobile number. Enter your mobile number here. Email address, rahul.sharma@email.com. Next, we enter the refractive error values. Original sphere, -4.5 diopters. Original cylinder, -5.25 diopters. These refractive values are typically obtained from the patient's spectacle prescription or from the manifest refraction performed during the eye examination. So, the values entered here correspond to the spectacle power measured during the patient's refraction test. Now, enter the central corneal thickness, 540 microns. This value is obtained from corneal pachymetry measurements, which are usually recorded during pre-LASIK investigations using devices such as corneal topography. Now click Calculate. The Zenfoancer LASIK Calculator now generates the treatment planning results. The first section shows the corrected prescription, corrected sphere, -4.5, corrected cylinder, -4.25. You may notice that the cylinder value has changed. The original cylinder entered was -5.25, but the calculator suggests -4.25. This change occurs because the calculator applies a LASIK nomogram. A nomogram is widely used in refractive surgery. It adjusts the treatment power based on expected surgical response. These adjustments consider factors such as corneal biomechanics, laser efficiency, and post-operative healing response. Because of this nomogram adjustment, the effective treatment cylinder becomes -4.25 diopters.
Now let's review the ablation depth calculations. Sphere ablation, 57.16 microns. Cylinder ablation, 53.18 microns. Total ablation, 110.34 microns. Next, the calculator evaluates different surgical flap techniques. These include ASA, Femto LASIK, and SBK LASIK. First scenario, ASA with a 60 micron flap. Residual Stromal Bed, 369.66 microns. Percent tissue altered, 31.54%. Undercorrection suggestion, none. Second scenario, Femto LASIK with a 100 micron flap. Residual Stromal Bed, 329.66 microns. PTA, 38.95%. Undercorrection suggestion, none. Third scenario, SBK LASIK with a 120 micron flap. Residual Stromal Bed, 309.66 microns. PTA, 42.66%. Slightly serious. Here the calculator suggests undercorrect cylinder to minus 3.0 diopters. This recommendation appears because the percent tissue altered, also called PTA, becomes higher. Most surgeons aim to keep PTA around 40% or lower to maintain corneal biomechanical stability. Now the calculator repeats the same analysis using a larger optical zone, 6.5 millimeters. Now the calculator repeats the same analysis using a larger optical zone, 6.5 millimeters. Because a larger optical zone requires more tissue removal, the ablation depth increases. Sphere ablation becomes 67.09 microns. Cylinder ablation becomes 62.5 microns. Total ablation, 129.59 microns. Now again, we evaluate the three flap techniques. A SA with 60 micron flap. Residual stromal bed, 350.41 microns. PTA, 35.11%. Undercorrection suggestion, none. Femto LASIK with 100 micron flap. Residual stromal bed, 310.41 microns. PTA, 42.52%. Suggested undercorrection, minus 3.25 diopters. SBK LASIK with 120 micron flap. Residual stromal bed, 290.41 microns. PTA, 46.22%. Suggested undercorrection, minus 1.75 diopters. These comparisons allow surgeons to evaluate the safest surgical plan by analyzing ablation depth, residual stromal bed thickness, and percent tissue altered.